Hello, folks. So let's get going with the whole Amazon Aurora Immersion Day workshop on AWS. So we stopped at testing fault tolerance. I believe when you see testing fault tolerance is basically whenever there's a fault, you understand that it gets tolerated and the system still works, and this usually is shown using high availability by saying that if one thing goes down, the other thing helps with running the system. So that's what fault tolerance is, then that's how you show it. And before that, I think in the last video I was looking at database insights and all. So this is regarding that, and we had noticed a lot of metrics and whatnot and logs. There were like a lot of logs that we saw yesterday, and you can actually see live tail and log insights also. Apparently only the last 500 logs are displayed, unfortunately, so you cannot see, say, the first logs that showed like the server started and stuff like that. So you can use the search field below to match the terms beyond 500 entries shown. We recommend using a data protection policy to mask sensitive data. Interesting. So you can search for newer logs, right? So maybe let me say server started something, server start. No, hasn't come up. And you can actually choose log groups. I think there are other log groups, for example, from the other clusters. And you click on live tail, you can actually see live tail coming up over here. So this is the live. Scroll to the latest events. So you'll notice that scroll to the latest event this moment. Scroll to the latest events, okay. So you should be able to see every few seconds. Yeah, can you see that? Like, it's coming up. New things are coming up, and it tells the log group also. And this is the local timestamp, and this is the server timestamp, right? So this is in UTC, and this is in my local timestamp, which is UTC plus 5 as 30 minutes. So this is live tail, and in live tails I've chosen only the Aurora MySQL cluster error and Aurora MySQL cluster slow query. You can choose other ones like, say, Lambda Aurora secret plain text Lambda, Aurora lab support, backtrack cluster, the IO optimized cluster and whatnot. And there are some more like standard storage, serverless V2, UPG, I believe it's the upgrade cluster, and then SageMaker, Aurora ML, churn endpoint, notebook instances. So I think this is live tail in general for everything and not just for RDS. So SageMaker and all comes up here, and even Lambda stuff comes up here. So it's getting live tail of the events, right? Select at least one log group, then optionally select one or more log streams by name or by prefix. So log group, we selected. Log stream, there's nothing over here in this case. Log events, you can tell. And yeah, you choose a filter and click on start tailing, and basically start. And during the tail, when the tail has started, you can pause the auto scrolling of events by clicking on any row, and click on the row actions icons to either expand the log event inline or via pop-up sliding pane. For larger events, enter multiple highlight terms. You can highlight up to 5 terms, not case sensitive. Use highlight to flag events that match your highlight terms. Use filter to limit the events displayed in the session. So you can use filter, and then there's actions. Timestamp, you want our local timestamp. Copy table to clipboard. Interesting. So filter clear will clear out the whole thing. and help find log events of interest and highlight the terms inside of your log event. If more than 500 log events per second match the filter, the log events that are displayed are a sample of the total log events to provide a real-time tailing experience. Tailing will be charged for the duration of the session by minute. Oh wow. Okay. So okay, so that is that. So this is Amazon Q. So yup, and interesting how this shows two idle. If I refresh or refresh like this, it still says two idle and is 8 instances not onboarded to database insights advanced. Few instances. Okay. Okay, so database, what is this? Database insights is standard for all of this. It's not advanced. For backtrack, IO optimize and all. For this one, it's you know it's advanced, so it's showing up here. And database instance, you should be able to see this thing. And yeah, SQL text, SQL metrics, database telemetry, logs, slow queries. This is what we are seeing here. And slow query logs. I don't think we have any slow queries, do we? Yeah. Events. Yeah. So you can actually go to Livetail and check out stuff and log insights also. For example, if you close this and open this up, you can choose one error logs, slow query logs, choose a to Livetail. Okay. So you are tailing one of the log groups, which is slow query logs. So and you just start. I think we don't have any slow query logs as of now. So this also shows there are 0 events per second. For example, in this case, is how many new log events per second match selected log group and filters, so that the session doesn't scroll by too fast. We might not display all events. Percentage is percentage of incoming log events that are displayed in the live session. Right. So if you cancel and then say filter and give one more filter, for example, the MySQL cluster error, and doing apply filters, and it will just do this. It will start it off. Now you'll actually see 100% displayed, 0 events as of now. But I think soon enough you'll see 1 event per second, and then you'll see it's showing all of them. 100% is being displayed, and 1 event again per second. And what is this log stream? Let's go look at that. And by the way, if you can open this up, so whenever you click on a row, it will start showing this. So you just click scroll, and so, and if you scroll up, it will again show like this. You scroll down also, it will show this. So you'll have to scroll to the latest, and if you click this, so you'll notice that this is the whole thing, and you can actually, I think, zoom in even too. You can open it up like this, I guess, and then oh, and this is actually resizable. So, and what about this? If you click this, I don't. Okay, so if you click this, you go to log groups. This log group exactly, and this one. Okay. So no more records within the selected time range. Okay. Auto retry paused. Resume. Loading newer events. Okay, so this is giving a specific time over here. with my local time zone. So display view in plain text 6. Okay, that's great. Column temporarily unmask protected data and all. Expand all rows. Interesting. Collapse all rows. Cool. So that is log events, and you can see the log groups basically. And if you click on one of the log groups, you'll see the log events, I guess. For example, this one, if you click log streams, if you click for one of them, I think you will see the log events. Yep. So that is that. And tags, anomaly detection, metric filters, subscription filters, contributor insights, I don't know what that is. Data protection, how do you protect the data, field indexes, transformer. Cool. So log analytics at scale is consistent and context. Yeah. So you can actually convert MySQL log format to JSON format or anything like that, right? And then if you click view and log insights, you will go to log insights and you'll come here and you can actually run the query and you'll notice the logs coming up here, patterns, visualization and all. Like if I say run query for this, fields, timestamp and all, and we've given 1 hour over here. So you'll notice the logs, and here are the logs. You can hide the histogram if you want. So I think this shows how many logs are there at every different time. So 9:15, 30 seconds, 9:16, 9:16, 39, 17, 18, and then 9:20. Right, 9:13, 15. Cool. So here you can actually see this going on, and I think the latest is shown on the top. Great. So this is last 1 hour. So yeah, this is not the latest time though. This is according to my local time at least. Yeah, this is not the latest time. It's a few minutes away. Anyways, so you can just say maybe last 5 minutes, and so fields at timestamp. I think it will take up this timestamp message last time. So and then run query and should give you the latest. I think I said last 5 minutes. So yeah, that is the latest. Almost the latest, not exactly the latest. So cool. So and you can see it says RDS database cluster and all that, and the whole log and which log stream, log group, log stream and all, and yep. So ingestion time, I think this is Unix POSIX timestamp. So that is that. So Amazon results name and everything, region, account and everything is mentioned here. Cool. So yeah, I mean you can actually click log insights and it will go to the same place like the log insights. So this is about the log stuff. Contributor insights, I don't know what it is. And live tail log anomalies and all, I think. Yeah, something to learn from. So of course CloudWatch has other stuff like some AI operations, alarms for alerts basically, metrics, application signals for application performance monitoring, network monitoring, and then insights, database insights is what we were looking at. So now let's close all of this and let's look at the testing fault tolerance. This lab will test the high availability and fault tolerance features provided by Amazon Aurora. You can find more details on the high availability features and connection management best practices in our documentation. These tests are designed to touch upon the most important aspects of failure recovery, okay, and are not intended to be exhaustive for all failure conditions. So in Amazon Aurora, high availability, which is HA in short, is implemented by deploying a cluster with a minimum of 2 DB instances, a writer in one availability zone and a reader in a different availability zone. We call this configuration multi-AZ, multi-availability zone. So the Aurora MySQL cluster you will work on is built as a multi-AZ cluster. In the event of a failure, the Amazon Aurora will either restart the database engine within the same DB instance or promote one of the reader database instances as the new writer, depending on the circumstances, to restore operations as quickly as possible. It is therefore recommended to use the relevant DB cluster endpoints to connect to Amazon Aurora, as the role of writer can shift from one DB instance to another in the event of a fault, and the cluster endpoints are always updated to reflect such things. So I think this is kind of like this endpoint that they give is kind of pointing to a proxy of sorts, probably, which ensures that it always points to the writer, and the reader endpoint points always to the reader. So your client application should not cache the resolved DNS response of all these endpoints. Makes sense. So if you cache it, then the IP address, I guess the IP changes for these DNS endpoints. So it's probably not a proxy. It's probably just changing the DNS record. So whenever there's an error, it should, for example, whenever the writer endpoint, the cached IP, it says error that you cannot write, it's a read-only instance now, then you should, TTL is apparently typically 5 seconds, should attempt to reconnect if disconnected, and should always verify whether the connected DB instance has the intended role, writer or reader. So this lab contains the following. So basically your client also should be good, or else there will be a problem. So this is true, I have noticed this. Or your infrastructure should have a proxy which stops connections whenever there is a switch from like one instance to another instance as the writer, like one gets promoted and the other one gets demoted, in which case the existing connections to the demoted one while it was getting written to are disconnected, and then the client has to make connections again, and that's when it gets connected to the newer primary or newer writer instance. So this lab contains the following tasks. So set up failover event notification. So you should get some notification or alerts or alarms basically saying that, hey, there's a switchover happening, and failover, switchover are all like similar terms. You can use it interchangeably, I think. Test a manual DB cluster failover, test fault injection queries, test a failover with cluster awareness. I'm not sure what that means. Okay, so use RDS proxy to minimize failover disruptions. More testing suggestions, clean up lab resources. Okay, cool. So let's go to this. So we are going to, okay, so for notifications, I think we're going to be using simple notification service. Makes sense. So to receive notifications when failover events occur within with your DB cluster, you will create an Amazon simple notification service topic, subscribe your email address to the SNS topic, create a RDS event subscription, publishing events to the SNS topic, and register the DB cluster as an event source. Okay. So if you have not already opened a terminal window, and we've done this. So we're just going to create a topic. I'm going to close this up, and let me actually store this up for later. Cool. So the topic is created, and yeah, so now subscribe topic ARN. We just got the topic. We just created the topic. So your email and notification endpoint, your email. Okay. So let's put this down. So let's actually, maybe let me just say new text file. So let me just give my email ID over here. larrytech.com, PBISNADARAJAN, capillarytech.com. Okay, cool. Can do this. Okay, pending confirmation. So we need to see the pending confirmation. I think I need to confirm it from my email ID. Let me do that. One moment. so let me actually pause this for a moment. Okay, so as you can see here, I got a message notification, like as a email from SNS, simple notification service, and to my email ID, and it just came out, and it says subscription confirmation. So you've chosen to subscribe to the topic. To confirm the subscription, click or visit the link below. If this was an error, no action is necessary. Please do not reply to this email. If you wish to remove yourself from receiving all future SNS subscription confirmation requests, please send an email to SNS opt out. Okay, so once we click this, I think it says subscription confirmed. You have successfully subscribed. Your subscriptions ID is this. If it was not your intention to subscribe, click here to unsubscribe. Interesting. So to subscribe, it shows a URL like this. I think the URL looks something like this. It's pretty big. So SNS US West 2, and let's just put this 1 moment. Okay, so confirmation topic, and then this is the topic, token, and then endpoint, and then yep, that's it, right? So the token is pretty big. I'm not able to. Yeah, it's a pretty big token. I think that's pretty big, yeah. Okay, and then so if you simply go to this, I think it will just say subscription not confirmed, could not be because your topic or token information is incomplete. Please make sure to use exactly the URL from the subscription confirmation message. Cool. So, and to unsubscribe, you have this link. So it's called unsubscribe.html, and the subscription, it gives the subscription ID, I think. So this is the subscription ID, right? And then okay, so you just need the subscription ID to unsubscribe, I guess. You don't even need a token and all. So yep, cool. So now one moment, let me just copy this and let me see. Yeah, that's the same thing. Cool. So I have subscribed. So I'm just gonna close this up, and we can actually probably check it out. Let me sign in again over here. Let me look at SNS and open it up, and we have one topic and one subscription. So we can actually see the dashboard which says one subscription, and it says this is the subscription ID, and its status is confirmed. Cool. Okay, and the topic is this, which is principal. I'm not sure what this means. IDE. Okay, I think this is the instance from where this happened, or which created this. Yeah. So yep. Cool. So you can actually see the EC2 instance which created this, the principle that they're talking about. I think it will say ID. There are 3 instances running. Interesting. So yeah, VS Code ID is what we've been using. The dashboard was showing some errors, API error, I don't know. I think we're not supposed to, we don't have access to this. Cool. So now if you've subscribed, you will receive a verification email on that address. Please confirm the subscription by following the instructions in the email. Once confirmed, or while you're waiting or for the verification email to arrive, create an RDS event subscription and register the database cluster as an event source using the command below. Okay, so we are going to be creating a event subscription, RDS event subscription. Subscription name is this, SNS topic is this, source DB type is database cluster, event categories is this, and so the subscription name is this, and Event categories is only for failovers, and then with this subscription name, we'll have a source identifier, the MySQL cluster. So, okay, register the database cluster as an event source. Okay, so let's create this first. Okay, so it says event subscription, customer AWS ID, customer subscription ID and all, and the resource name and so status, active subscription time, aggregation time, okay. Failover, event subscription, ARN, okay, so this is RDS, ES is event subscription, I guess, and then so yeah. So service, region, account ID, and then the I think sub resource type or whatever, and then the resource name or ID, I believe, and then finally we create this, add the source identifier as this database cluster. So we have it, and I think we're good. I think enabled true. I think it's the same thing now, but there is a source also. Source type, no, source type is there, and I think something extra maybe. Status, SNS topic, status, subscription, source type. Oh yeah, source type, and then source list is there now. Cool. Now, so yeah, they're showing us how it will look like. Right, at this time the email notifications have been configured, and ensure you have verified your email address before proceeding to the next action. We have verified our email address, and that we want to receive the subscription. It's not just verifying the email address, so yeah, it's both of them. So in this test, you will use a simple failover monitoring script to check the status of the database. Okay, so this is the monitoring script. So let me actually get this down. I will probably create a folder for this monitoring script. I'll say new folder inside this AWS Aurora Immersion Day workshop. Cool. Monitoring script, I don't know what script this is. This is a Python script. Okay, .py. Let me put this in. Right, so this is the script it's using. So it says Amazon Aurora Labs for MySQL, simple Aurora DB cluster failover monitoring script, leveraging only the DNS endpoints. This script this script connects to the database using cluster endpoint approximately once a second, and checks the role of the database engine. If it cannot connect or it connects to a reader instead, it counts the elapsed time. Dependency is none. License, the sample code is available under the MIT license. So yeah, so you have sys, argparse, time, socket, random, Python, MySQL, datetime, JSON, URL library, third version, and then OS, the environment variable thing, and finally, so you have the endpoint, and so we have track analytics, and so this is for tracking the analytics, doing some analytics thing for stack UUID and stuff. So, and then finally you have the loop indefinitely, resolve the endpoint. So you basically get the endpoint, connection start time, take timestamp, okay, and then connect with the endpoint, username and password, and database. So information underscore schema, so this is, I think this is a schema that is always present, probably a metadata schema. So auto commit true, connection timeout 1, DB read only, Aurora server ID, Aurora version, connection.cursor as cursor, and then server ID version. So you get the different these is reader, server ID and version. So and then greater than 0 is reader, or else if it's 0 then it's writer. So yep. um, and then connection end time, connection close, initial, is it the initial thing? While true, and then initial is true, okay. And as reader, you've connected to reader endpoint, try connecting to the cluster endpoint instead. Cool. So maybe let's try out connecting to the reader endpoint by mistake and see let's how that goes. Let's see how that goes. So if in the middle of a failover, if failover detected, how does failover get detected? I think initially it is false. So else, if reader is greater than 0, then it is a reader detect failover. This is a reader, and now we have to say no longer in the initial loop. So basically failover detected, false. Oh, sorry, failover detected true. So if there is a thing, detect the failover, display error, connected to reader, DNS is stale. So else this, connected to, and then all that, and then initial is false. Finally, once one of these things happens, right? So and then finally you sleep for 1 second, and then if there's a keyboard interrupt, you stop. It's stopped by the user itself. So when there's a PSQL my error, so like not my Python MySQL error, then you just get the error message and get the error code and message error code 200, can't connect, assume failover. If you can't connect, you just assume there's a failover. So one of these, then detect failover is not detected. Failover start time is equal to connection start time. So okay, so try before this, I think. Okay, and then can't connect to the database. Okay, and then this one. I think these are some error codes we can probably go ahead and look at. If the proxy, if it says proxy hyphen or something, then again failover detected, or else it just says MySQL error, unexpected MySQL error encountered, right? Cool. So what else? Finally, any other error bailout? So you say unexpected error occurred. Okay. Cool. By the way, we also have a lot of samples and stuff available here. We'll just download these, or we can download this itself. No, we can't. Okay, we'll just download these together. Think I'll go here. Okay, view files, save changes. So I think we should be able to view the files now. Yeah, it's getting downloaded now. Yeah, it says 27 files, 33 files, 37 files. Yeah, it's coming up. Just a moment. Okay, so we have the change log. I don't know what this is. Oh, this is just a samples directory. I think there should be other things coming up here. Interesting. I said download the whole thing. Hmm. Let's just say old here. Let me try to get. Okay. Can I download this alone? Okay, yeah. Can I download these? Is this downloading allow? I should allow multiple files. Cool. Bank deposit. Okay. Aware failover. So now we have weather performance, simple failover, serverless to demo, SageMaker policy.json, replicate Python, reader load test, peer VPCs, delete cluster.python, DB access test, database activity stream reader, DB access test here, delete cluster, yep, and reader load test and all that. Okay, client requirements, bank deposit, aware failover. Okay, so yeah, let me just download this. Yeah, it is 47 files, 48 files, 50 files, 55 files, 60 files. Yeah, it's coming up. Cool. 69 files. $72 files. Cool. I think that's it. These two, I think I'll give these two too. Let's see this. Sysbench TPCC and 0 ETL. Let me see if that comes up. Sysbench TPCC, yup. Cool, it's coming up. So here, do I have something like FD? No. Anyways, I think I've got all the ones that I need here. 367 files, 367 files, and 0 ETL. I think 0 ETL is an empty directory, is it? Okay, cool. Nothing to download really then. Cool. So I like how this shows rerun command, copy command output, run recent command, learn about shell integration. Cool. It shows that there was an error over here. For example, this one says it all worked well, right? This one says nothing has been run. Cool. So now so we did check out the monitoring script. So learn more about the simple monitoring script. Okay. So the script is designed to monitor the writer DB instance. It will attempt to connect to the database cluster endpoint and check the status of the database instance by executing the following SQL query. So InnoDB read only 0 for writers and 1 for readers. This global system variable indicates whether the storage engine was opened in read-only mode or not. Aurora server ID, Aurora lab hyphen something. This is the value of the database instance identifier configured for that particular cluster member at creation time. Aurora version. This is the version of the Amazon Aurora MySQL database engine running on the database cluster. Note these version numbers are different than the MySQL version. So in the event of a fault, the script will report the number of seconds it takes to reconnect to the intended endpoint and the writer role. If you have not already opened a terminal VS Code, okay, and you will need an additional terminal window as well. You will execute commands in one and see the results in the other. Next, on the right panel, you will find the layout view. Select your current session to perform a horizontal split. Please see the screenshot below. Okay, so in one of the two command line sessions, start the monitoring script using the following command. Okay, so let's run the following command. So let me get the cluster endpoint. I'll get the read-only endpoint once, and let's see how that goes on. It will say it's a read-only endpoint. Okay, that simple failover basically. I think that simple failover is basically this only. Yeah. Okay. So that's why they said monitoring script. I think the simple failover.python web. Cool. I'm just gonna go ahead and run this. So it'll say press Ctrl C to quit this. You've connected to a reader endpoint. Try connecting to the cluster endpoint instead. Unexpected error occurred. Cool. So it does tell the right thing. So now we just need to give the writer endpoint, which is this, I believe. One moment. Yeah, that's the writer endpoint. Cool. So now we'll just run this, and while this runs, we'll actually do a we'll have a split terminal, and so basically you can split the terminal by actually, I think, like doing this, and you can also close the terminal by getting out like this, Control D, or typing exit or quit. I think quit also works. Okay, exit works, not quit. Cool. So then you can do Control backslash, I think, or I don't know, I forgot the thing for this for split terminal. Command backslash, command backslash, and you should be able to get that on command backslash. Yep. And if you say Control D, it should come out. Cool. So quit core down. Okay, let me keep doing this. So here I'm gonna actually now. So in the other command session, you will trigger a manual failover of the cluster. During this process, Amazon Aurora will promote the reader as the new writer DB instance and demote the old writer. So promotion demotion happens, the old writer to a reader role. The process will take several seconds to complete and will disconnect the monitoring script as well as other database connections. All DB instances in the cluster will be restarted. Enter the following command in the command line session that does not run the monitoring script. So failover DB cluster. So we are saying failover, we are manually failing it over. Right. So let's manually fail it over, and it's done. Right. So here you can actually see that we've triggered the thing. So availability zones, backup retention, database name, all that, endpoint status is available. So now you can see actually it can't connect to the database. MySQL error 2003, right? And then failover completed, took 7 seconds, connected to this node 2. So this was initially node 1, right? Now it's node 2. So I think it will say can't connect, and when it says connected to, it says the server ID, server role, and then version. Okay. Server role is writer only. Okay. Uh, server ID I think is the this thing connected to, yeah. Server ID gives which is what is it node 1, node 2 and all that. So yeah, we are connected to node 2 now, and that is the writer. So promotion tier 1 looks like there's a promotion thing happening. Preferred backup window, master user. So these are all fine now. These are the same things, and engine mode provisioned, tag list. Cool. So I think the only thing here is promotion tier has happened. If I fail it over again, let me see. Can I fail it over again? It should go back to node 1. Yeah, it is not connected. Can't connect. Can't connect. Can't connect. And then connected to reader. DNS is stale. Okay. So failover completed, took 13 seconds. Node 1. So node 1 is again the writer. Let me fail it over again. And I'll just cat this, I think. Yeah. Cool. So can't connected to the reader. Failover completed. Awesome. So node 1 connected to reader. Yeah, there was some weird thing happening here. I think when we were on, so initially node 1 and then node 2, we did one failover and then we did one more failover, and then node 1 became the writer. And then I wanted to do the failover and ensure that node 2 is still the writer. So I did the failover again, and for some reason it connected to reader. I don't know why. DNS is stale. Okay, so basically the promotion happened and one became reader, and hence it said connected to reader. Okay. DNS is stale, and then failover completed, connected to node 1. Node 1 is writer, and then again it says connected to reader. DNS is stale. There was something weird happening here. Anyways, let me keep up the logs. Yeah, forgot that I was keeping track of the logs. I should keep track of the logs. My bad. Cool. So yeah, these also. Yes. Cool. So now we have this. So wait and observe the monitoring script output. It can take some time for the Aurora, Amazon Aurora to initiate the failover. Once the failover occurs, you should see monitoring output similar to the example below. It says it took 10 seconds. Observations. Initially, the cluster DNS endpoint resolves to the IP address of one of the cluster DB instances. Node 2 in the example above. The monitoring script connects to that particular DB instance and determines it is a writer. So when the actual failover is implemented by the AWS automation, the monitoring script stops being able to connect to the database engine, as both the writer and the reader DB engines are being rebooted and reconfigured. After several seconds, the monitoring script is able to connect again to the DB engine, but DNS has not fully updated yet, so it still connects to the old writer DB instance, which is now a reader. This underscores the importance of verifying the role of the engine upon establishing connections or borrowing them from a connection pool. So the monitoring script correctly detects this discrepancy and continues attempting to reconnect to the correct endpoint. Cool. So if you are not able to connect, you connect back again, and if you connect to a reader, then it's a stale DNS. So you probably try out again the DNS thing. I need to understand this part. So after several additional seconds, okay, it continues. So the monitoring script correctly detects the discrepancy and continues attempting to reconnect to the correct endpoint. So anytime you connect and it says reader, you just wait and try to resolve the DNS again. So probably it's cached maybe, and so here, okay, I removed it. We can see it here. Anyways, for now I'm just gonna go ahead and finish this other stuff. Later I'll come back and look at these. So after several additional seconds, the monitoring script is able to connect to the correct new writer DB instance in the example above. After the cluster endpoint has been reconfigured automatically to point to the new writer, and DNS time delay has expired client side. In the example above, the total client side observed failover disruption was around 9 seconds. In the event of a true hardware failure, you will likely not be able to connect to the old writer instance, but the client may attempt to connect until that attempt times out. A very low connection timeout value in the client MySQL driver configuration may delay recovery time for a longer period of time. However, there are other use cases where you would want to initiate a manual failover, such as scaling the compute of writer DB instances with minimal disruption. So because of the nature of DNS resolution and caching, you may also experience a flip-flop effect, as clients might cycle between the reader and writer for a short span of time following the failover. Okay, so looks like we did notice that flip-flop effect. Feel free to repeat the failover procedure a few times to determine if there are any significant variances. Okay, so just a moment. Cool, let's get going. So you will also receive 2 email notification emails for each failover you initiate. So one indicating that a failover has started and one indicating that failover has completed. Okay, interesting. Let me go ahead and look at that. One moment. I think I'll have to I'll have to stop the recording to be able to see that. Okay, I'll show that later maybe. So now the difference between the notification timestamps of the 2 event notifications may be larger than the actual disruption observed during the using the monitoring script. So the monitoring script measures the actual disruption observed by the client, while the event notification reflects the end-to-end failover process, including subsequent service-side validations once the DB cluster is operational again. Cool. So testing fault injection queries. So in this test, you will simulate a crash of the database engine servers on the DB instance. This type of crash can be encountered in real circumstances as a result of out-of-memory conditions or other unexpected circumstances. Makes sense? So fault injection queries. So we will actually keep it handy. So provide a mechanism to simulate a so these are like a query that you can use to simulate a fault. Provide a mechanism to simulate a variety of faults in the operation of the database cluster. They are used to test the tolerance of client applications to such faults. They can be used to simulate crashes of the critical services running on the database instance. These do not typically result in a failover to a reader, but will result in a restart of the relevant services. Simulate this subsystem degradation or congestion, whether transient in nature or more persistent. Simulate read replica failures. Connect to the MySQL cluster endpoint using a MySQL client in the terminal window that does not run the monitoring script. Okay, so we should keep running the monitoring script. We'll keep running it, and we'll connect the thing. So that is the endpoint. Okay, and so the thing is simple failover. We have hyphen endpoint, but we use hyphen image. So we'll run this. We are inside the cluster. So we'll say now issue the following fault injection command. Okay. So it says lost connection to MySQL server during query. No connection, trying to reconnect. Here it says can't connect to the database. Failover completed, connected to MySQL node 2. Great. Okay, so yeah, I mean here I think basically it says error 2003 and before that 2013 connection thing. Can't connect to MySQL server on this. Error, can't connect to the server. Now if I just say select one, I think I should be able to connect. Yep. Cool. No connection, trying to reconnect. Connection ID 45, current database my luck. Cool. So it retried and it got connected. So there was a failover. So observation, when the crash is triggered, the monitoring script stops being able to connect to the database engine. Yep. So that happened here. So after a few seconds, the monitoring script is able to connect again to the database engine. The role of the database engine has not changed. It is the same node 2, and it is still writer only. So the role of the database instance has not changed. The writer is still the same DB instance MySQL node 1 in the example also. In this example it's 1, for us it's 2. No DNS changes are needed. As a result, the recovery is significantly faster. In the example above, the total client side observed failover disruption of 4 seconds. You may need to exit the MySQL command console even if it is disconnected using by typing quit. Okay. So testing a failover with cluster awareness. Okay. So simple DNS based failovers work well for most use cases and they are relatively fast. However, as you have noticed, there are still several seconds of connectivity disruption due to DNS update and expiration delays, including the DNS flip-flopping effect. I need to understand what is this flip-flopping effect. Okay. So thus failover times can be improved further. Okay. So in this test, you will use a basic cluster aware monitoring script. Okay. So let's actually say cluster aware monitoring script.py and we'll just put it in this. Okay. So this is cluster aware. So how does it know about the cluster though? So ends with, okay, split the DNS name. Okay. Is this a DNS endpoint? Okay. Connect. Server role is not equal to writer and our initial server ID, get the master server ID. Okay. And server role is this. So instance ID, you do not provide a valid Aurora DB cluster and DNS endpoint. If you are using a custom CNAME, adjust the topology detection accordingly. Detection or detention. Okay. And I'll leave it. So looks like they try to understand, does it end with this? And they actually get the identifier and then temp one. Okay. So interesting. So I think this is the current endpoint, and when they say identify current master. Why did they overwrite the temp 0 though? I don't know. Temp 1, they're replacing it with cluster hyphen is replaced with nothing, and then RO hyphen is replaced with nothing, read only. Custom hyphen is replaced with nothing, so validate endpoint. So is not equal to 12, or if the thing is not equal to 6, non-conforming endpoint DNS name provided. Okay, interesting. So I think this is based on the size of that thing. So I think it's about this. So this is 12 characters, by the way. So I think this is some unique ID that they have. So any read-only RO or cluster and whatnot, they remove it, and they check any custom things in between, and then finally, they check it out. Writer endpoint, they say join. So okay, so they basically get what do you say? This cluster identifier, database identifier, along with this, with a hyphen, and then so once they get this, if server role is not equal to this, and then reconnect to the right node if the role is not the right one. It is writer, so it will be writer initially. So if it is reader in the master endpoint, so if it is writer only, then it goes here, connection close, initial. If failover detected, no. Failover will be detected only. I think failover is detected only when. So initially it will not be detected. So if it's reader, then failover is detected, or else it's just connected to this thing and that's it, right? So let's say it is reader at this point, it closes the connection, it connects, reconnected to writer endpoint, master endpoint. So query status, it didn't run the command, it's just the command though, you have to run the command. Here is where it gets the query status. Connection endpoint or connect endpoint is this. We want to continue using the master endpoint until we have a connection issue. So okay, so we say this, and then false. If this is false, it comes here. The reader, if it is reader, then yep, or else still connected. If it is reader, then it says connected to reader, and then DNS is tail. Right. So once this happens, I guess resolve the endpoint. You resolve the endpoint, however, every time. So cool. So now I think the only thing they're doing over here is extra is something around the domain name, and they're using this master endpoint for what though? They're just using it over here, that's all. Nowhere else do they use it. I don't get the point of this thing though. So reconnect to the right node if the role is not the right one. So you have the master endpoint, but if you are reader, then you reconnect. So it's like one time connect here. If it is reader, then you connect again, right? So I wonder how this works. I need to think about this. Anyways, so the script is similar to the simple monitoring script above. So basically, You'll use the cluster aware, basic cluster aware monitoring script and compare it side by side with the simple monitoring script used above. Learn more about the cluster aware monitoring script. So the script is similar to the simple monitoring script above with a few significant differences. Initially and after each failure, at reconnect, it queries the database cluster topology to determine the new writer DB instance. Okay. The topology is documented in the in the information schema replica host status table in the database and accessible from each DB instance. Oh, are they getting this? Okay. They're actually getting this also. Okay. They're not just getting they're not just using this, by the way. The other one used this, yes. Nowhere did you use the replica host status. Okay. So if it is the initial thing or if it's reader, we get the master server ID. Okay. So replica host status where session ID is equal to so we get the current master basically, right? So instance endpoint, current master. Okay, but what's the point of it though? Okay, if the master endpoint is there, it says reader, so you get the master endpoint. Server role now. You still have server role as reader, let's say, as initial. Later it becomes reader somehow. Then reader, you have the master endpoint, of course. Then if you don't, then you have exceptions. So if you have the master endpoint and if you're a reader, then close the connection and reconnect to the master endpoint. Okay, so master endpoint basically will be reconnected to writer endpoint, and I think this will actually not be the whole endpoint. Instead, it will be very specific. Okay, so this is interesting. Okay, so the topology is documented in the information schema.replica host status table in the database and accessible from each database instance. So if the current database instance is not the writer, it simply reconnects to the database instance endpoint of the new writer directly. Okay, so upon encountering a new failure, it falls back to using the cluster DNS endpoint again. So assuming you still have the two terminal windows open and active, open a third terminal window from the right hand side layout panel. Click on the split button again to open a third terminal. So in the new start the cluster aware monitoring script. So you can't quit the monitoring script. You can quit the monitoring script at any time. Okay. So we're going to be using the cluster aware failover also, apart from using this. So let's just do that. Cluster endpoint. Let me just close this. So let me close this too. Cool. So we'll have one more terminal. So we'll start this over here, and we'll start the cluster aware thing over here. Yeah. So now I think at some point both of them will become yep. So you can see them going together now. Okay, so now we'll actually see So enter the you can put, so unlike the simple DNS monitoring script from step 2 above, you can even use the reader endpoint to invoke the cluster aware monitoring script. However, the cluster endpoint is still recommended. So apparently you can use the reader endpoint also. So I think if you use the reader endpoint RO, so connected to the writer endpoint, great. So it connected to the writer endpoint on its own. So initially I connected to Aurora lab MySQL cluster dot cluster hyphen RO. Now it just connected to MySQL node 2 and dot this. It connected to the writer endpoint. It found out basically the thing directly, but I'm going to use the writer endpoint only. So let's just do this. Okay, so enter the following command in the command line session that does not run any monitoring script to trigger the failover. Okay, so I need to actually I'll have one more this is okay, so I'll have to actually I'll connect to this and this. Can I use watch here? Let me say help, quit reprompt, help, no pager, pager, clear, no warnings, no, watch, show warnings disabled, no, true. Anyways, okay, I'm just gonna go ahead and just say select one or something, and I'll try to do that here also again. So we can actually see that it says connected to Aurora, right? I'm gonna copy this and run it here. Let's see how this goes. So at some point there should be a issue over here. Let me connect here. Oh wow. Okay, so in between it said can't connect. Okay, here also it says can't connect. Connected to reader. This is all connected to reader. It directly reconnected to the server role is reader. Writer ID is this. Reconnected to writer endpoint. Here you can see how the DNS is still stale, and here it's already connected. Wow, that's nice. So you can actually see how it's pretty cool that this is pretty fast. I think all the clients should use this. It should be aware of the cluster. I think even in our company, I think we should use this. Wait and observe the monitoring state output. It can take some time for Amazon Aurora to initiate the failover. Once the failover occurs, you should see monitoring output similar to the example below. So here you can actually see can't connect, connected to reader, DNS is stale, failover took 11 seconds, actually failover took 6 seconds and all that. So observations, When the crash is triggered, the monitoring script stops being able to connect to the database engine. After a few seconds, the monitoring script is able to connect again to the database engine, detects that the role of the database engine has changed. It queries the topology of the cluster, discovers the new writer DB instance identifier, and computes the database instance endpoint. It disconnects and reconnects to the new database writer directly using the database instance endpoint. In the examples above, this process took 6 seconds to restore connectivity compared to 11 seconds when relying exclusively on the cluster DNS endpoint. The initial cluster DNS endpoint is still authoritative and preferred. The cluster-aware monitoring script only uses the DB instance endpoint as long as it works, reverting back to the cluster endpoint when a failure is encountered. This ensures that connectivity is restored as quickly as possible, even if there is a total compute failure of the writer DB instance. Feel free to repeat the failover process a few times to determine if there are any significant variances. As before, you will also receive 2 event notification emails for each failover you initiate, one indicating that a failover has started and one indicating that it has completed. Cool. So let me actually try this out again. So I'm able to connect now. So it says connected in both. This one, let me just say cat after this, and let me connect. Okay, I think failover is not yet happening. Yeah, failover happens. Can't connect to server. Here also can't connect. Here it connected already. The DNS is stale over here though. Failover completed, connected finally. Here it got connected. As you can see, failover completed happened here itself. The failover completed happened here instead. So at 5:20:17 instead, it was actually at 5. DNS is stale again over here, 5:20:22. So you can actually see DNS is stale here, 5:20 and all that. Failover completed again, 5:20:23. Here it happened at 5:20:13 itself, 5:20:14 itself, failover completed. Here in 5:20:22, it is still actually doing stuff. 1 second, yes, but before there was some 10 seconds and whatnot. Totally some in between, some 11 seconds of downtime instead of 6 seconds. Cool. So now we can actually, I think, stop this, or actually, let's just go on. In this test, you will create an Amazon RDS proxy for your database cluster. Use a simple monitoring script to connect to it. Invoke a manual failover and compare the results with the previous tests that connect directly to the database. Learn more about Amazon RDS proxy. Amazon RDS proxy is a fully managed, highly available database proxy for Amazon relational database service that makes applications more scalable, more resilient to database failures, and more secure. RDS proxy minimizes application disruption from outages affecting the availability of a database by automatically connecting to a new database instance while preserving application connections. When failovers occur, rather than relying on DNS changes to reroute requests, RDS proxy routes requests directly to the new database instance. I think this is what I was talking about, where the connections to the old writer get cut and the new writer get formed, and looks like application connections on the other side are still preserved. So open the Amazon RDS service console. Ensure that you're still working in the correct region, especially if you're following the links above to open the service console at the right screen. So navigate to proxies in the left navigation menu. Cool. Proxies. Okay. So do we have any proxies? No, we don't have any proxies. So create proxy, and then in the proxy configuration, set engine family value to MariaDB and MySQL. Set the proxy identifier to Aurora Lab MySQL proxy. Okay. So create proxy, MySQL, PostgreSQL, SQL Server. This is, I think, Microsoft SQL Server. This is for Aurora MySQL, RDS for MariaDB, and RDS for MySQL. So Aurora Lab MySQL proxy. The target group configuration, choose MySQL cluster and database dropdown, leave all the other default values as they are. Okay. So idle client timeout 30 minutes. Okay. So I think if you make this smaller, no, it is responsive only. MySQL cluster, yep. Connection pool, maximum connections 100. Oops. And here 100. Add reader endpoint. For example, if you've set the maximum connections to 5000, specifying 50% allows your proxy to create up to 2500 connections to the database. Okay. 100%. Okay. Maximum allowed connections as a percentage of the maximum connection limit. Okay. So proxy can create all maximum connections. So additional target group configuration, session pinning filter. Session pinning associates your application connection to a database connection from the proxy for the lifetime of the application connections. I don't know what these are. Connection borrow timeout. Timeout for borrowing DB connection from the pool. Okay. In the database connection pool, I think we need borrow a connection. So initialization query, specify one or more SQL statements to set up the initial session state for each connection. Separate statements with semicolons. Identity and access management, create IAM role. Secrets, manager secrets. And then client authentication type, caching SHA-2 password. And then has certain limitations if you don't use TLS while connecting your proxy. Create a new secret. Select secret. Yeah, we are not gonna list clusters on document DB. Okay. Anyways, just gonna close this up. Not allowed, required. So you can use IAM authentication to connect to the proxy in addition to specifying database credentials. Choose how you want to use IAM authentication with this proxy. The choice applies to all secrets you associate with this proxy or with the proxy. Only IAM authentication, database credentials can't be used. Allow only database credentials for is turned off. Okay. So I guess this is turned off. Connectivity, require transport layer, security, subnet groups, additional connectivity configuration, VPC security group and all. Enhanced logging. With enhanced logging, details of queries processed by proxy are logged and published to CloudWatch blogs. Okay. Because enhanced logging plans slow down performance, it's automatically disabled after 24 hours. Interesting. Why is it disabled after 24 hours? Then should you have to enable it again? Anyways, I don't know. So they're asking to keep all the other configurations as default, all other default values as they are, and in authentication section select keep IAM role selection for IAM role. In the secrets manager drop down, choose a secret with a name that starts with secret cluster admin user. Okay. IAM, where is it? It's here. So yeah, this is the one. And in the connectivity section, expand the additional connectivity options. And for existing VPC security groups, choose Aurora Lab database security group. Deselect the default security group and click create proxy. Okay. So security group, subnet is all fine. Choose existing Aurora Lab database security group. Deselect this. Okay. And click create proxy. Okay. Cool. Do we have enhanced logging? No. Yes. So that is that. Creating a proxy may take several minutes. You may need to refresh your browser page to view the up-to-date status information. Once the status is listed as available, click on the proxy identifier to view details. Okay. So apparently it will take several minutes. Okay. In the proxy endpoint section, locate the endpoint with target role set as read or write. Make a note of it. You will use it later. Okay. So read or write. So this one we need to get it. Next, you will need two terminal windows open in your VS Code. ID. Use a split button to create and MySQL simple failover. You can quit the monitoring script at any time. I think I'll use both of them and I'll see how it goes. In the VS Code, it will trigger a manual failover. Okay. So let me actually stop these now. So I'll actually copy this. And this. And this. And this. Cool. So let this keep running and I'll be triggering a failover here, and I'll be running this command aware failover and simple failover, the client side, right? This is just a client. So now let's wait for the proxy to be available, and for RDS proxy I'll just say this cluster failovers. Does it show if anything has come up? No, I don't know. Subscription dead letter queue in case it doesn't go, I guess. Okay. Push notifications, topics. If I open this topics, can I see the data in this topic? Delivery status login. Anyways. Cool, so I'll close this up for now. And I wanna actually, what did I copy? Yeah, I need to put this here. Okay, so I'm gonna have to wait for the proxy to be available. This is still in creating status. This is gonna say okay. Creating a proxy might take up to 20 minutes to create and become available. A secret in secrets manager and an IAM policy that accesses the secret for use with this proxy. Secret in secrets manager and an IAM policy that accesses the secret for use with this proxy has been created. To view resources, these resources, click the proxy's details page. Okay. View proxy, RDS proxy, and target groups, authentication. You've created it. Great. We click not allow, is it? Damn shit. I think it should have been allow. I don't know. Need to password. Instead we chose caching shadow password. Anyways, so I think it has to create because I don't know. Let's see if it works. First of all, status isn't creating. So let's see. 20 minutes is a lot of time anyways. So once you do this, you get the endpoint and you'll use that. And when you failover, wait and observe the monitoring script output. It can take some time for Amazon Aurora to initiate the failover. Once the failover occurs, you should see monitoring output similar to the example above, example below. So initially the proxy sends traffic to the current writer of the database cluster, node 2 in the example above. The proxy forwards the monitoring script queries to the particular DB instance, to that particular DB instance. Then the actual failover is implemented by the AWS automation. The proxy holds the client connection open until the failover completes. In this example, the script only experiences additional second of latency to the response. You can actually see 7, 8, then 11, 1 second, that's all, 11, 12. Additional second of latency to the response, but the response is not provided by the new writer in the example above. In practice, the client experienced 2 seconds of latency to the query response. The timing of requests issued by the client or monitoring script in this example matters. If the query is in flight at the time the failover starts, or you are attempting to establish a new connection while the failover is ongoing, the proxy will return an error so you can retry. Existing client connections with no in-flight queries will be kept open, and any queries received after the failover starts will be queued up at the proxy until the failover completes. Such clients will simply experience increased response latency. Okay. So if the query is already in flight, right, as in it's being executed, so you're attempting to establish a new connection, so then proxy will return an error. But the failover is going on. After the failover has started, you send a new query, right? Any queries received after the failover starts, it will be queued up at the proxy until the failover completes. Such clients will simply experience increased response latency for the queries issued during the failover. Can this queued up thing be cancelled? I don't know. So feel free to repeat the failover procedure a few times to determine if there are any significant variances. You'll also receive 2 email notification emails for each failover you initiate, one indicating that a failover has started and one indicating that it has completed. Cool. More testing suggestions. So let's see. Oh, this is created. Awesome. So you can actually click this. You can also close this. You can use this URL. I think this can be deleted, but this cannot be deleted. This is the read-only part. So I think we'll be using the proxy. Let me see if I can actually use one more terminal to just use the proxy instead of this endpoint, right? Let me put this down and aware failover. This is simple failover. Okay. So I'm gonna start this off. I'm gonna start this off also, and then I'm gonna start off this. It says name of server is not known. Why? Why is it that the case? Oh, I made a mistake, sorry. Weird, I think I copied something in between, something I did. Anyways. Cool. This one's gonna be this. MySQL error, access denied for administrator using password, yes. Unexpected MySQL error encountered. Okay, I think I think this is actually using a different password. I should have said native password instead of this. Let me actually try to get the password for this one. It shouldn't have been this. Can I change it now? I think I can't change it. Can I modify? I want, so has certain limitations if you don't use TLS. Okay, can I make it as native and modify proxy? So it's modifying. Let's see. So we have many more things in our thing. So anyways, I think we should be able to finish this all soon in 24 hours time. So let's see if this is being done. Yep. So let's look at the other testing suggestions in the meanwhile. So the tests above represent relatively simple failure conditions. Different failure modes may require more advanced testing processes or cluster awareness logic. For more advanced testing and fault resilience, consider the following. So, how would production load at scale affect failure recovery time? Consider testing with system under load. How would recovery time be affected by the workload condition at the time? Okay. Consider testing failure recovery during different workload conditions. Example, a crash during a DDL operation. So, can you improve upon the cluster awareness to address other failure modes? Okay, cool. So, you can clean up the lab resources. So, deleting the topic, deleting the database proxy, and all. Okay, let's wait for this to be done. And then next, I'll be actually looking at identifying SQL performance issues. Once we have this, I think this is the simple failover, and I'll also be running the aware failover also, cluster aware failover. I'll have one more tab open here with that. So I just need to run these once this is done. We have some recommendations here. I think one is high and all that. I think it's about the upgrade, your major version before October 31st, 2024, and it's beyond October 31st, 2024. We are in July 12th, 2025, and the file resources are not running the latest minor database engine version. Have only one DB instance, add a reader DB instance. Okay, so this has been done. So if I click here, it should say MySQL native password. Okay, cool. So now if I connect, okay, it's still not connected. Access denied for user. Using password, yes. I'm not sure why this happened. Should I create this again? Or is this just taking some time? Interesting. I think the password it uses is different. I'm not sure though. It's secret cluster admin user. Secrets manager. Okay, and this is OTWCK. This is the one. This was created at July 10th. This was created. Okay, I think we'll have to use a different user. Interesting. Okay. The password, secret name, version, secret value, retrieve secret value. I think it's this, which is different from the other password, I think. Not sure. Yeah, I think the password here is different. dbpass. WR1 SUT, it's the same. Weird. Um, okay. What about this? Retrieve secret value. Oh, this is redshift. No. Hmm. Interesting. Not sure why I'm not able to connect here. MariaDB, MySQL proxy, Aurora MySQL cluster, create IAM role. Did I give the Aurora Lab database security group? It is Aurora Lab database security group, and this should have the outbound rules. Interesting. Unfortunately, I'm not able to connect to the proxy now. It is access denied. Should I just delete this and create it again? Delete me. Aurora Lab MySQL proxy. MySQL proxy. Create DB proxy is some. Interesting how it shows MySQL native password now. proxy 2, let's just say. Successfully deleted proxy. Okay, now can I create? Array, you just deleted it. I thought it's deleted. It's still in deleting state. Okay, let's just say MySQL proxy 2. So you can't have hyphens at the end. Note, you cannot have two consecutive hyphens or hyphen at the end. Okay. Proxy 2 and yep, I think that's it. Don't have to do anything else, I think. Everything else is by default selected, I think. Create proxy. Okay. So this is creating, this is deleting. Cool. So we'll be using this endpoint. This will still not be available yet because it says name of service not known. Yeah. So this one. Yeah. I'm gonna actually run this out and then we'll see how things go. So proxies, let's wait for this to get created. This is going to take quite some time, I think. In the meanwhile, we'll keep these ready. Oh, these are all inside pipe bash, so yeah. Orient shell, sh shell or bash shell. Bash. Cool. Let's see if this is done. Yep. So it's available now. And the other one is also deleted. Let's see if this gets connected. Can't connect to the database. At least something is happening. It says can't connect to the database. I don't know why. Can't connect. In the meanwhile, I'll also check how watch is done in MySQL. MySQL watch command. The watch command in conjunction is also Basic syntax, watch. Oh, the MySQL shell provides its own reporting commands show and watch, and that can be more efficient for monitoring. Okay. Yeah, like highlight changes, execute command directly. That can be useful in different scenarios. So I think we can just use /watch. I don't know why it can't connect to the database. Ideally, it should be able to connect to the database. Oh, one of them is in creating state, one available, and the other one is in creating state. Weird that it can't connect to the database. So I'm gonna be just doing watch. Select one. Don't think MySQL shell watch. I wonder why this failure. Can't connect. This one, watch threads. No, what? I don't know what this is about. Threads report. I think we have to use MySQL SH and not MySQL. Is there something called MySQL SH? MySQL SH? No, MySQL, that's all. Come in. So let me see if I can actually connect to MySQL. Nope. So it says using a password in the command line interface lost connection to the MySQL server at reading initial communication. Oh, now it's able to connect. Okay. This is the proxy and it's able to connect. It says access denied. Weird. How come this works? Oh, I have a problem in my in my UI, in the thing that I mentioned somehow rds.amazon.aws.com. Damn it. So I think it should have been this. Server role is writer. Non-conforming DNS name provided. Okay. I think I made a mistake over here alone. Yep. Of course, I made this mistake. Okay, so proxy. It says it's a non-conforming proxy. Okay. Okay, so in aware failover, you can't use the proxy. I think not possible to use. Okay, but you can use it in simple failover. Yeah. Okay. Okay, so we can't use this. So now I'm going to be using this, and I'm just going to be saying select one. Since I can't just watch it, I'm just going to run it. And I'm just going to do a failover here, and let's see how it goes. Yeah. So let's see. So here we can already see can't connect to the database. Can't connect to the data. Connected. Okay, here. It's connected. This was always running, huh? Oh, cool. Did I use a proxy? Yeah, I did use a proxy. So here, let's see where this connection issue happened. Nowhere, huh? Here it happened just a moment ago. Okay, let me stop these and then I'll know what is happening. Okay, so just take this out. And see over here, it says it took 14 seconds. Right? Okay. This one, it says it took 7 seconds. So this is this is the cluster aware thing, right? Okay, so we didn't get the exact. Okay, anyway, there's a lot of logs, so of course it won't show the whole thing. This will simply show connected to another. Anyways, it's fine. So here, this shows it was always connected. There was no error. Wow. This one, yeah, I mean, this is cluster aware, can work only with the cluster environment, not with proxy. And this one also was always working fine. Right. So maybe if I actually run the failover again, I'll know how it looks like. Let me actually keep all of these ready. I think this will not work, so this is fine. I'll keep this ready. and then let's say tuck, tuck, tuck. Okay, cool. So I'll just keep running this and I'll just run this once. Let's see how much can't connect comes up. Can't connect has come up in the first two. Here it says connected. So failover completed in 11 seconds. Here the failover completed in 8 seconds. You can see here. So, oops. You click that. It's like a link. Anyways, so we can stop it here. Stop this here. Stop this here. So the first one was this is simple failover. Here it took 11 seconds. Connected to the reader, DNS is stale and all that. Right here, this is the cluster error failover. It took 8 seconds. This is the proxy with simple failover. Proxy, and it didn't have any connection issue anywhere, right? Let's see when this happened, right? Can't connect at 6:04, right? Till 6:4:16, some 9 seconds or 8 seconds. In the cluster aware one, so this is cluster aware one. This one is 6:47. 6:4:19, so 16 or so 11 seconds. 6:47. Let's see what happened at 6:47 in the proxy one. So 6:47, nothing happened. Everything was fine. Wow, I don't know how, but anyways, it's directly connected to 2, as you can see here, from 1 to 2, and yep. It's all good. Cool. So I think it's pretty cool. So it just switched from 1 to 2 over here with the proxy, and okay, cool. So now that we have looked at this, we'll actually close these tabs. And we'll actually run the cleanup of database resources. Proxy not found. Okay, we have to actually remove the thing named as proxy 2, not proxy 1, but proxy 2. This is called proxy 2. Yeah. Cool. So we have that also done. Okay. So this proxy should be gone. So yeah, it's deleted. This proxy should be gone. And what else? The SNS topic and all should be gone. So let's look at the SNS topic and the event subscriptions and all. So event subscription, and then source identifier, SNS delete topic. So you can't delete the topic without deleting the subscriptions, I think. So subscription is gone. This subscription we can just delete it, I think. Yeah, because there's no source and all that. So high throughput FIFO topics, first in first out. Okay, so let's look at RDS. We had some subscriptions, I think. Yeah, event subscriptions. I think events were also probably there. Yeah. So you can actually see the latest events that happened. So how many failovers, right? You can actually see there are so many 88 events over here. Automated cluster snapshot, instance shutdown, and whatnot. Instance restarted. And today we had done like performance insights has been enabled, disabled, and all that. So you can actually subscribe to these events, I think. So source was MySQL cluster for us. So source identifier, subscription in source MySQL cluster, right? And remove the source identifier and then remove the event subscription itself. So we had an event subscription, but now it's gone. But you can actually see that DB instance was restarted and all that. MySQL node 1, MySQL node 2, and then the completed customer initiated. A new writer was promoted. Completed customer initiated failover. So it says started cross AZ failover and started cross AZ failover, right? And then database shutdown. So and then new writer was promoted, restarting database as a reader. To DB instance. So basically, this has to become the master. So first of all, they stop it. So a new writer was promoted this and restarting database as a reader for 2. And 1 is just restarted, 2 is also restarted, and then finally 1 becomes the thing. And so you can actually see when 2 is the thing, finally they say 2 is completed. We'll look at all the emails for this. I'll show that in the next video. Yeah. So I think that's it. And you can also see how proxies were created. It doesn't show link to the proxy because we deleted over here, that's why. So created endpoint, read only, and all that, deleted and whatnot. I think deleted, this thing should come up here again. Yeah, deleted the endpoint and all that. Yeah. Cool. So yeah, that's all I had for this video. I'll see you in the next one where I'm talking about observe and identify SQL performance issues, and I'll also show you the notifications that I got in my email. That's all I had for this video. I'll see you in the next one. Bye bye.